welcome back to McClutchy Maths. My name is Natalie McClutchy and today we are continuing our video series on the 2024 external exams in Queensland, Australia. And we're looking at some multiple choice questions 2 and 7 from paper 1, and our focus today is on networks and decision mathematics. Now before we get going, I just want to let you know how you can engage further with us here at McClutchy Maths. Firstly, you can consider liking and subscribing the video and hitting that notification bell so you'll know when new videos are available. Why not tell someone about the video or even share it in your class OneNote? You can even tell us in the comments if you found the video helpful. And there's a new way that you can engage with the channel here and let us keep making videos that help and support you. And that's by hitting that super thanks button and donating $2 using your secure and confidential PayPal account. All right, let's get going with our first question of 2 questions. Question 2. In a graph, an open walk with repeated vertices and no repeated edges is called and we've got some choices: bridge, loop, path, and trail. And this is all about our networks vocabulary. So let's go through these one by one and define what each one is and see if they fit that initial definition. So first of all, a bridge. Now a bridge has a type of edge that connects 2 separate networks with one single pathway together. So this is what a bridge looks like. Now it's got nothing in there about repeated edges or repeated vertices. It's just simply one single path connecting 2 different networks. So the only way you can get from 1 to 6 is to go through the bridge. So bridge is not what that open walk is called. Okay, the next one that we can look at is a loop. We can eliminate loop from the actual definition because it's a type of edge that goes from one vertice back to the same vertice. It forms a literal loop, like a little circle. Now, I could have in this open walk, I could have repeated edges, I could have repeated vertices and still have that loop sitting there. This loop is not this part here. So let's eliminate that one. And that leaves us with a path or a trail. And we're quite familiar with Eulerian types of networks and also Hamiltonian ones, usually done in a cycle. So let's see if we can work out whether this is a path or a trail. And this is where we really need to have our definitions memorized. So a path is a walk with no vertices repeated. Okay, except for the vertex, that's the start and the finish one. So here, this is about repeating vertices. This one is none are repeated. Path is not it, which only leaves us with trail. And let's look at that trail definition. It's a walk where there's no edges repeated. So that's this one here. So that would be D, is the only possible option. Okay, let's move on to our second question. This is a decision mathematics type of question. The table shows information for a project with 4 activities, W, X, Y, and Z. They've got different durations. I can see that 2 of them have no prerequisite, which means they are the 2 starting activities. So the question is actually wanting me to focus on W. What is the float time for activity W in minutes? So this is activity W up here. So basically it's asking us if I've got this, I could sit there and I could draw the whole network if I wanted to. It's not really helpful because I know from my formula that the latest starting time, take away the earliest starting time, take away the activity duration if it's later in the network, then that would give me my actual float time. It's the amount of time that I'm going to be sitting there doing nothing while I wait for the rest of activities to happen. So I've got 4 take away 0, which is my latest starting time, take away my earliest starting time, which gives me a total of 4 minutes. And that is my only possible option out of all of the 4 options, option C. Well, that's all of the decision-making mathematics and networks questions that were in paper 1 for multiple choice. If you've got any questions about anything you saw today, mcclutchymaths@yahoo.com is the place to reach me. You've been watching McClutchy Maths. I'm Natalie McClutchy. Have a fantastic day.